In this video, I'm going to focus on position versus time graphs for objects that are accelerating. Well, what is acceleration? We're looking for objects that are changing their velocity over time, therefore they're speeding up or slowing down. So think about a car sitting at rest at a stoplight, the light turns green, steps on the gas, and all of a sudden the car starts to speed up. Here's just a sample lab that shows accelerated motion. We're going to release this cart from rest on the inclined ramp. It's going to start at a position of 0, and it's going to end at a position of 6. Our goal, though, is to track the position changes for the first 3 seconds. So I filled in the time from 0 to 3. I filled in the first 2 positions. It starts at 0. In the first second, it moves 1 meter. And the goal is to fill in the 2 blanks at the bottom left. Well, let's zoom in on each successive change. In the first second, I'm saying that it moves 1 meter. So let's say from 0 to 1 seconds, that's as far as it goes. Now, for the second second, from 1 to 2, we would expect its position to change at a greater rate. In this case, from 1 to 3 is my example. If it only changed a meter, that's a constant velocity. Because we expect this cart to speed up, it should change its position at a greater and greater rate. And you see that again in the final second from 2 to 3. Now it's going to change 3 meters because again it's speeding up. Trying to put this on a position versus time graph, we'll start with the first second from 0 to 1. I'm going to put a line that connects 0 meters to 1 meter over that second. Now we'll put the second change from 1 to 2, and you'll see that it's a steeper line because it's got to now cover 2 meters in that second. The third line gets even steeper, now 3 meters over the course of 1 second. So this is a general shape of something that's speeding up. You can see that the slopes are getting steeper and steeper. We've previously discussed that the slope of this graph is velocity, so if the slopes are getting steeper, the velocity is getting faster. But this doesn't match, real life acceleration. Back to our car example. If a car, speeds up from rest to 20 miles per hour, it's not that it goes 0 miles per hour, then 5, then 10, then 15, then 20. Rather, it's hitting every speed from 0 all the way to 20. It's gradually speeding up. So I'm going over this method as a way to get a general outline for the acceleration or the direction it's speeding up, but you'd want to fill it in with a curve later because a curve is a constant slope change, just as we expect it to constantly be changing its velocity. Let's look at another scenario. Again, we're going to release the cart from rest, but now we're going to flip the ramp around so that the cart starts at 6 meters and ends at 0 meters. Because this ramp is downhill, we expect the cart to speed up as it travels. Our goal is to fill in the blanks of the table while we construct the graph. Notice the times are filled in, and it starts at a position of 6. Well, in the first second, we would have a slope that is not very steep. The cart is just starting to speed up. It wouldn't be moving very quickly at the end of this second. Let's say it covers just 1 meter, so it goes from 6 to 5. In the next second, the cart's now moving faster. So in a single second, it's going to cover more ground. Let's say 2 meters. It goes from 5 to 3. You see the line gets steeper. And the same is true in the final second. It's moving its fastest. It's going to cover the most ground. I have it going from 3 down to 0. So this is a way to construct the general shape. We see the cart moving from 6 down to 0, so we know it's moving in the negative direction. All of these slopes trend downwards, and because the slopes are getting steeper and steeper, we know that it's speeding up. So fill in a curve later. This would show something that's always speeding up, as opposed to just having 3 kind of jagged velocities throughout its motion. Another one, this for you to try. We're going to start at the bottom of the ramp, so now moving uphill, but we're starting at a position of 0 and ending at a position of 6. Notice that the cart is already moving at the bottom of the ramp. Now, in a real scenario, the cart would move up the ramp and might even come back down. But we're going to restrict our analysis to when it's moving upward on the ramp and slowing down. See if you can fill in the table and construct the graph yourself. Go ahead and pause the video. I'll walk you through it in a minute. Okay, the general outline would look like this. The fastest the cart will go is at the beginning. So from the first second, we're going to go 3 meters from 0 to 3. In the middle of the ramp, the cart is slowed down to a medium speed, and towards the top of the ramp, it's moving its slowest. So we see our jagged velocities go from steep to not very steep, and we'll fill in the curve later. This shows something moving forward because the line is trending upwards, and this shows something that is slowing down because the slope is getting less and less steep. The last one we need to try is where we're moving backwards and slowing down. So notice the cart is starting at 6 and approaching 0, that's the backwards, and it's traveling uphill, so we expect it to slow. If you want to try to fill in this table and construct this graph, I put the answer in the attached worksheet. You can head there to see how you did. To summarize, position versus time graphs that curve can be challenging. There's just a lot of options. But if you can break your analysis into two areas, I think it makes them easier to understand. First, focus on the difference between speeding up and slowing down. Objects that speed up have slopes that get steeper, and objects that slow down have slopes that level off or get less steep. Next, focus on the difference between moving forward and backward. Objects that move forward in the positive direction have lines that trend upward on the position axis, whereas objects that move backward or in the negative direction have lines that trend downward.